4.2. This is intended to be done after having done 4.3 below, because if you're doing the series to learn programming, there are some fundamentals here that absolutely have to be covered before we can look at algorithms such as this. Do keep in mind that the original intention of 4.2 is to just go over the pseudocode, the logic of these things, but we are also using this to learn programming. So 4.2.1, describe the characteristics of standard algorithms on linear arrays. This is a fairly big one actually, because it includes the binary search, sequential search, bubble sort, and selection sort. So we'll take each one of these in turn, starting with the most straightforward one, which is sequential search. So I've got this set up to do all of these, and what we'll be doing is calling them from a main method. So I've already done the headers here, or at least stubs of the headers, not quite everything, not return values or parameters, but let's do that now. And I've got a couple of arrays here. I guess since it'd just be easier to use this one because we've already got numbers there. Remembering the two different ways to declare arrays. This one as yet has no values in any of its 10 elements. This one does. It's declared explicitly, we can see. Now the question is, will it be void or not? For now, let's just make it void. Sequential search. And will it take any parameters? Probably, but for now, let's just leave it like that. And call it. Right, so the idea of a sequential search is, through an array, you look at each element in turn, looking for a search element. So if I was searching for number 8, I would say, is this 8? No. Is this 8? No. Is this 8? Yes. And if it was, at the simplest version of this, I'd just return the element number. I'd say, yes, 8 is at number 0, 1, 2 of this array. It does exist there. So we're calling this from the main down to here. Will we need any parameters? Well, yes, we'll need the array to start with. So let's copy this. So this is an int array called that. So we're receiving it, sorry, and we're also sending it. And the other thing that we're going to need will be what we're searching for. So let's just send the number 8 to see if the number 8 is there. So as a parameter, we will need an int, we'll call it key. Key meaning the key thing that we're looking for. So we call this sequential search. We send the array that we've already made. It is received here as a parameter. And maybe I won't call it another int array. Let's just call it before e. It's received, or let's just call it ARR. ARR, right? So another int array is sent and received, and 8 is sent also as an argument and received as the parameter key. Well, I already said we're going to loop through every element of this. So since we know how many elements there are, that is a set number of iterations, therefore we will use a for loop. So for int I is less than how many? Well, we could count them up, but we don't necessarily know how many elements there are. But we can get that from the array itself by going array dot, and then you'll see up at the top there is an attribute length. Starting at 0, less than the length. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. The last one is numbered 8 because we start at 0. 3, 4, 5, 6, 7, 8. So less than the length 9 gives us up to and including the 8th. And as we go through that, let's just keep this simple and not look for all the instances. For example, you can see there are a couple of 2, 3, 4s, but let's just, for this one, keep it at is there this in the array? And we'll just loop through and return as soon as we find it. So we're going to go if the array, its element, I, in other words, array 0, array 1, array 2, array 3, array 4, and so on. If any one of those, as we go through this one at a time, and these are ints, so equals the key, in other words, equals 8, then we have found that it is there. So we are going to return, we'll return the I. When we go return I, we're saying, okay, we're returning an int. And I have yet to change the return type of this, so I'll do that right now. Public static int. I'm going to return an int. Now it's going to say we don't have a return at the end of the method, but we're going to. So basically we're going to loop through. If we find it, we return the element number, but if we don't, so down here we can go return some sort of a flag value. -1 is quite often what is used. And you'll see that got rid of the thing that it didn't like there before. So as we loop through this, we're either going to interrupt the sequential search when we find, like with 8, what we're looking for, or we finish the loop not having found it. If we were looking for 62, there is no 62. Go all the way to the end, didn't find it, so we jump down to line 26 and return a -1. That's the sequential search. Implemented by a call from the main method, well, this wouldn't do anything because we just have this kind of going poof into thin air because this evaluates to what is returned, which is an int. So what we should do, let's put this inside it. We won't go that much further with this, but just a little bit. Let's go if, or how about we return the value? Let's go int returned value is that. And that'll work because we are returning an int. So then we can maybe up here in the main say if return value equals -1. You know, it's up to us maybe in the main method how we're using the sequential search. It can be used by many main methods, but in our main method here we are just testing this. So we're going to go sout the value we sent was. Okay. Else, for this instructional one, we'll just say element number and then the return value, which is, yeah. So if I just run this, I hope I've got a semicolon there at the end, do I? Yep. Okay, we'll run it and see, and that'll be it for sequential search. We are looking for 8 in that array, and it is there. It is at element number 2, 0, 1, 2. Maybe I changed again, but I think you see that how it works.